All right, and now we're going to change the mole to look at a different thing. All right, we're still counting numbers of particles, whether they be atoms, molecules, or formula units. All right, but we're going to change this a little bit because in our last notes we were worried about this. We were doing molar mass where we used the molar mass of sodium chloride, said it was 58, and that's 58 grams if I had 1 mole of it. Then, according to the question, it said I don't have 58 grams, I got 60 grams. And we ended up with this down here. So that was all via molar mass. Well, now our set of notes is going to have to do with a thing called molar volume, right? And volume has to do with gases only. So it says molar volume of gases. Well, according to your notes, it says molar volume of gases is 1 mole of any gas. Doesn't matter what gas we're talking about. All right, this is one great thing. We don't have to do this part up here, that addition thing concerning sodium chloride or anything like that. All we got to do is go, yeah, it's a gas. That's good. And then we got to worry about, the only thing we have to know is that it's at standard temperature and pressure. So if it's at standard temperature and pressure, then it always takes up 22.4 liters. So STP, standard temperature and pressure, is 0 degrees Celsius and 1 atmosphere. That's what standard temperature and pressure always is, 0 degrees Celsius and 1 atmosphere. 1 atmosphere, remember, is a unit of pressure, and then 0 degrees Celsius is temperature. Right, so we ended up with this ratio then that's in your notes, and that is we end up with 22.4 liters is 1 mole. And again, it doesn't matter what gas we're talking about. So I'm going to go to the other side and go, well, that's question mark over question mark. So whatever they give us in the question. This side over here never changes as long as we're talking about standard temperature and pressure of a gas. A gas at standard temperature and pressure, if I got 1 mole of it, it's always going to take up 22.4 liters. So now in your notes, I gave you an example. And that was, what volume is 3 moles of carbon dioxide at standard temperature and pressure? I did put a little G after that. That was to indicate that it's a gas. Notice that. That comes from way back when, in our notes, way back in the fall. So what we're going to do is we're going to utilize this equation. And on this side, they told us we got 3 moles, so I'm going to put that in the bottom. And we're talking 3 moles of carbon dioxide gas. And they want to know, well, what's the volume? So we want to know X liters of that. So cross multiply, you get X times 1 equals 22.3 times 3. If you multiply that out, you get 67.9. Whoops. How did I end up with that? Oh, I see what I did wrong. I'm sorry. Excuse me. That has to be 22.4. I don't know what I was thinking. So 67.2. There we go. Excuse me on that. I made a mistake. So now, what is the units for this? Well, we were trying to find out liters, so that's liters, and it's carbon dioxide gas. So we end up with, if I had 3 moles of carbon dioxide gas, then it would be 67.2 liters of it. Now, at the end, I asked, well, what if we change this to water vapor? All right, water vapor would be H2O as a gas. Not H2O as a liquid, it's H2O as a gas. Does anything change? Nope, I don't have to recalculate anything, because remember, it's always 22.4 over 1, no matter what. Therefore, we'd have X over 3 moles, but the one piece that would change would be this. It would change to water as a gas. Therefore, when I do all my calculations, everything would be the same except this. I'd end up with 67.2 liters of water as a gas. That would be the only thing that would change, would be my units as to what am I talking about. I'm not talking about carbon dioxide anymore as a gas. Now I'm talking about water as a gas. So these calculations I like to think are pretty easy because this side never changes. So all we're looking for is, if they gave me moles, they're asking me the volume. Then I'm going to utilize this equation. All right. So with that, that's really all the notes on this one. This is a nice little short set of notes, only 4 minutes and 4.5 minutes long, basically. So now we're going to move on and do some problems on this down the road here. So we'll talk to you later. See you.